Okay, we are looking at a few more relationships within circles and how those pieces and parts relate to each other. So, starting off with another new theorem. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So very similar to our inscribed angle that we talked about, that the measure of the angle is half of the measure of the arc. So looking at example 1, it says line M is tangent to the circle. Find the indicated measure. So we want to find this measure of angle 1. Well, we know that it's half of the 132 degrees that it's opening up to of its intercepted arc. So half of 132 is 66 degrees. And if we want to find the measure of arc EFD, well, we know the angle is half of the arc, so we need to double that angle measure. So we get 220 degrees. Our next theorem, if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, so I want to talk through this with some specific examples. So, for instance, if we are trying to find the measure of angle 1, it is half of the two arcs added together that it opens up to, its intercepted arcs. So it opens up to CD, and then its vertical angle opens up to AB. So it's half the measure of AB plus the measure of CD. So kind of like taking the average of those two arcs. We can do the same thing if we want to know the measure of angle 2. It's half of BC plus AD. So the measure of BC plus the measure of AD. So looking at example 2, I see angle X is what I want to find. I want to find the value of X. So X is equal to half. It opens up to 140 degrees. And its vertical angle opens up to 112 degrees. So 140 plus 112 is 252. So then X is half of 252, which is 126 degrees. Okay, now if we have angles outside the circle, it says if a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. Okay, so the formulas are going to look nearly the same, except we're talking about difference instead of sum. So we're going to subtract the arcs. So since they're outside, we have the measure of angle 1 is equal to 1/2. And we're going to do the further away arc minus the closer arc. So BC, so the measure of BC, minus, instead of plus, the measure of arc AC. Looking at this middle one where we have two tangents, I have the measure of angle 2 is equal to 1/2. And I'm going to subtract the measure of PQR minus the measure of PR. Remember, we have to name with 3 letters. That differentiates those two. The final one we have has 2 secants. So the measure of angle 3 is equal to 1/2 the measure of xy minus the measure of wz. Let's try a problem. So find the value of x. So our angle is equal to 1/2, and since the angle's outside, we're going to be subtracting. We have 170 minus 72. So 170 minus 72 gives us 98, and half of 98 is 49. So x is 49. All right, this one says find the value of y. But just because that's our unknown doesn't mean that's going to go on the left-hand side of our equation. Our angle always goes on the left-hand side. So we set this up as 26 equals 1/2. And then we do that further away arc, or y, minus 30. Now there's a couple different ways you can solve this. You could distribute, or you could divide by 1/2, which would be the same as multiplying both sides by 2. I'm going to go ahead and distribute that 1/2 out. So 26 equals 1/2 y minus 15. I'm going to add 15 to both sides. So 26 plus 15 gives me 41 is equal to 1/2 y. Now, divide by 1/2, which is the same as multiplying by 2. So these cancel. 2 times 41 then is 82 is equal to y. Alright guys, if you have any questions, come in and see me. If not, I will see you in class.